When we think of global conflict, we usually picture battlefields. But today, the biggest conflict is being fought somewhere else entirely. It's happening in our supply chains. It's a quiet war, a showdown between high-tech chips and the rare minerals they're made from. So let's dive into this tech war and see how it's literally rewriting the rules of the global economy.
Okay, let's just start with one number. Negative 55%. What on earth is that? Well, that's the staggering drop in China's exports of a critical mineral called germanium in just 2 years. Now, this isn't just some market fluctuation. Oh, no. This is a calculated shot across the bow in this new economic conflict, and it shows you just how high the stakes really are.
And here's the absolute key to understanding this whole thing. It is an asymmetric conflict. You can see it right here. The US is leveraging its near monopoly on designing the world's most advanced chips. And on the other side, China is leveraging its control over processing the very minerals you need to make that technology. It's like a strategic duel, where each side is targeting the other's biggest weak spot.
So yeah, that's what this is all about, an asymmetric tech war. You really have to think of it like a global chess match. Each country is using its unique economic power, not just for trade, but as a strategic weapon to slow the other side down in really critical areas.
All right, let's look at America's side of the board first. Their strategy is pretty direct. They're aiming for a technological chokehold. The goal is to squeeze China's ability to produce the most advanced computer chips, the brains behind basically all modern military and economic power.
And this wasn't just a solo move. The pressure ramped up, and it ramped up fast. It all started in October 2022 with these huge U.S. export controls. But look at this timeline. Just a few months later, by early 2023, the Netherlands and Japan were on board. Now, why does that matter so much? Because that's where you find irreplaceable companies like ASML and Tokyo Electron. Suddenly, you've got this incredibly powerful, coordinated front.
And the target list was surgically precise. We're talking about the most sophisticated equipment on the entire planet. Things like EUV lithography machines, these are the tools that print circuits that are almost impossibly small. The controls even went after people, restricting U.S. citizens from working in China's chip industry. That's a huge deal.
So what's the end game with this chokehold? Well, the official goal is all about national security. It's designed to hit the brakes on China's development of advanced military tech. We're talking about military AI, hypersonic weapons, electronic warfare, all things that absolutely depend on having these elite-level chips to work.
Okay, so now let's flip the board and look at China's countermove. They didn't hit back with their own chips. No, they went for the jugular in a different way. They targeted the very raw materials you need to make the chips, flexing their incredible dominance in mineral processing.
I mean, think about it. How does a country that's dominant in minerals fight back against a semiconductor superpower? You can't just build the same multi-billion-dollar machines overnight. It's not possible. So you do something else. You identify and control the key ingredients that your opponent absolutely needs and can't easily get anywhere else.
And this is exactly where China played its hand. They weaponized minerals. But they didn't just pick any random materials. They chose their weapons very, very carefully. Germanium, gallium, graphite. And what do these all have in common? For every single one, China has a dominant, sometimes almost total monopoly on the world's processed supply.
And the tactic they used here is just fascinating. China didn't go for a big, flashy, outright ban. Instead, they set up an export licensing system. And that is a much, much smarter weapon. It lets Beijing turn the tap on and off, approving or denying shipments whenever they want. What that does is create massive uncertainty in the market and apply pressure quietly, without causing a huge international incident.
To really see how this works in the real world, let's just zoom in on one of these elements that's caught right in the middle: germanium. It's the perfect case study for seeing the real-world ripple effects of these high-level political decisions.
So why germanium? Why is it such a big deal? You've probably never heard of it, but I guarantee you, you're using it right now. It is absolutely essential for things like infrared optics and military hardware, the fiber optic cables that are the backbone of our internet, and even specialized transistors inside 5G base stations. It's everywhere.
And, well, the market reaction was instant and dramatic. Just look at this price chart. We set the baseline to 100 right when the US controls hit. Then, after China announced its new licensing system, bam, the price jumped 40%. And as things kept escalating, it soared to 80% higher than where it started. You can literally see the economic impact in real time right here.
But price is only half the picture. The actual volume of germanium getting out of China, well, it just fell off a cliff. Before all this, China was exporting around 85 metric tons a year. By 2024, that number had plummeted to just 38 metric tons. That's the 55% drop we talked about right at the start. This is a real supply shock, and it's being felt all over the world.
This table really sums it all up, doesn't it? It's the tale of two completely different strategies. On one side, you have the US approach, which is narrow but incredibly deep, focused on those key chips and chip-making tools. On the other side, you have China's approach, which is much broader, covering a whole range of critical minerals. The US is leveraging its tech leadership, while China is leveraging its industrial dominance in processing. Each side is fighting from its own unique position of strength.
So what's the big takeaway from all this? Where is this all heading? You know, the biggest long-term consequence isn't just about some temporary price hikes or shortages. It's about the very fabric of our global supply chains, which are starting to tear apart and fragment.
See, the real long-term story here is this incredibly expensive, time-consuming race to build brand new parallel supply chains. Western countries are now scrambling to do something they haven't bothered with for decades, building their own capacity to process these minerals from the ground up. And let me tell you, that is a process that's going to cost billions, take years, and it's going to fundamentally change the global economy.
And this whole situation gives rise to a new term that I think we all need to get familiar with, the decoupling premium. What is it? It's pretty simple. It's the extra money, the premium, that companies and governments are now willing to pay to get these essential materials from anywhere but China. It's the price of security. It's the price of breaking that strategic dependency in this new, more fractured world.
And really, that's what this all boils down to. It leaves us with this one final, really critical question. As we move away from a single, integrated global system to a more fractured one with competing supply chains and these built-in decoupling premiums, we really have to ask ourselves, what is the true price of technological independence?